In our next section, we're going to talk about the wireless local area networks, and let's start with the wireless local area network overview. So, why we need wireless networks? In today's companies, wireless networks are a powerful tool for boosting productivity and encouraging information sharing. With untethered access to documents, emails, applications, and other network resources, employees can roam where they need to and have constant access to the tools required to do their jobs. That is the main reason that explains the need for the wireless networks. And let's go ahead with the advantage of the wireless. The first advantage, increased mobility and the collaboration. Employees who use your wireless LAN can roam around your office or to different floors without losing their connection. Imagine everyone in a team meeting or in small conferences having access to up-to-the-minute communications and all documents and applications on your network. The second advantage is the improved responsiveness. Customers want quick response to queries and concerns, guys, and a wireless network can improve customer service by connecting staff to the information they need. For example, a doctor in a small medical office can access online patient files while moving between exam rooms, or a retail salesperson can check on available inventory necessary to write up orders on the showroom floor. The third advantage is better access to the information. Wireless LANs allow a business to bring network access to areas that would be difficult to connect to a wired network. For example, adding wireless access points to a warehouse can make it easier to check and manage inventory, providing the company with accurate inventory figures in the real time. And the fourth advantage is the easier network expansion. Companies that need to add employees or reconfigure offices frequently will immediately benefit from the flexibility wireless LANs provide. Desks can be moved and new employees can be added to the network without the effort and the cost required to run cables and the wires. The most common wireless technologies used today are Wi-Fi, Bluetooth, WiMAX, cellular broadband, and the satellite broadband. Let's go ahead with the IEEE 802.11 Wi-Fi standards. 802.11 refers to a family of specifications developed by the IEEE for wireless LAN technology. These specifications, this standard specifies an over-the-air interface between a wireless client and a base station or between two wireless clients. In this chart, you can see the history and the enhancements of the standard. The first standard is 802.11 as you can see, and the maximum data rate is 2 megabit per second just, but the last standard, which is 802.11 AC, is supporting up to 7 gigabit per second, and you can see the bands that the standard are using and the bandwidths they support and the modulation type and advanced antenna technologies. Let's go ahead with the verses again. This chart explains some differences between wireless local area network and the wired LAN. Physical layer component of wireless local area network is radio frequency, and the physical layer component of the Ethernet is cable, as you know. Availability of the wireless LAN is everybody in the range of the access point, while you need a cable connection on the Ethernet local area network to reach the network. and we can face with the signal interference for wireless local area network, but it is inconsequential for the Ethernet local area network. And let's go ahead with the wireless network interface cards. A wireless network interface controller is a network interface controller which connects to a wireless radio-based computer network rather than a wired network such as Ethernet. This card uses an antenna to communicate via microwave radiation. And let's go ahead with the wireless modem. A wireless modem is a device that provides wireless broadband connections such as DSL for home users over the Wi-Fi. Most of us use modem in our houses and connect to internet by using modem or wireless. Let's go ahead with the business wireless solutions. When 802.11 networking began, all access points were autonomous mode, which means that each AP access point worked as a standalone unit with no knowledge of or interaction among other access points. Autonomous mode was fine in the beginning when wireless networking was often limited to providing network access in common areas or boardrooms, and continuous roaming was not a requirement. Rather than using autonomous access points, you can use lightweight access points too if you have a network component that offers wireless local area network controller services. In this scenario, the access points all have their configuration managed by the wireless controller. You can set a single policy on that wireless controller, and that configuration setting can be deployed to all managed access points, reducing the workload of managing hundreds of autonomous access points. Let's go ahead with the wireless antennas. An antenna gives the wireless system three fundamental properties: gain, direction, and the polarization. And we have three types of antennas, and they are omnidirectional, directional, and the Yagi. The directional antennas are designed to be pointed or focused in a single direction, somewhat like a flashlight. Omni antennas collect and broadcast signal in a 360-degree pattern, similar to how a light bulb throws light in all directions. And Yagi antenna is a directional antenna consisting of multiple parallel elements in a line. And let's go ahead with the .11 topology modes. We have basically two topology modes for wireless network, guys, and they are ad hoc mode and the infrastructure mode. Let's start with the ad hoc mode. In the ad hoc mode, two devices connect each other wirelessly without the aid of an infrastructure device such as a wireless router or access point. As you can see in here, we have laptop 1 and laptop 2, and they are connected wirelessly to each other without an access point. In the infrastructure mode, wireless clients interconnect via a wireless router or access point, such as in wireless local area network. In the infrastructure mode, wireless clients interconnect via a wireless router or access point, such as in VLANs. In basic service area, we have just one access points to connect. As you can see in here, we have laptop 1 and laptop 2 again, and these guys are this time connected to each other by the help of an access point. And in extended service area this time, we have 2 or more access points to connect, and our laptop 1 is in here, for example, and our laptop 2 is on the remote end, as you can see, and they are connected to each other by using 2 or more access points. Let's go ahead with the wireless LAN operations, and let's go ahead with the Wi-Fi frame format. In the Wi-Fi frame, we have 2 bytes of frame control field, we have 2 bytes of duration field, 6 bytes of destination and source and the router MAC address field, 2 bytes of sequential control bit, 6 bytes of MAC address of the AP, and we have data, payload, and the CRC fields. Let's go ahead with the CSMA-CA. Carrier Sense Multiple Access Collision Avoidance is a protocol for carrier transmission in 802.11 networks. Unlike CSMA-CD, Carrier Sense Multiple Access Collision Detect, which deals with transmissions after a collision has occurred, CSMA-CA acts to prevent collisions before they happen. And let's go ahead with the client access point connection. The client sends a discover AP message to discover the access point in the network. Then an authentication message is shared between client and the access point. Then the associate message is shared also between the client and the access point. To connect an access point, we have 5 parameters, and they are SSID, security key, security and network mode, and the channel setting. SSID is the short for service set identifier, and basically SSID is the name for a Wi-Fi network. Security key is the password that we are using to connect to wireless access point. We can also set the security and network modes and channel settings too. In wireless network, guys, frequency channels are used for communication between sender and wireless receiver devices. If channel is used so much by clients, it can saturate. And to decrease the saturation, we have different types of techniques, and they are DSSS, which means direct sequence spread spectrum, FHSS, which means frequency hopping spread spectrum, and OFDM, which means orthogonal frequency division multiplexing. And let's go ahead with the wireless local area network security, and let's start with the wireless DOS attacks. Despite recent Wi-Fi security advances, wireless local area networks remain very vulnerable for denial of service attacks. While traditional DOS attacks involve overwhelming a host with service requests, in wireless networks, limited bandwidth and routing functionality associated with nodes open up new avenues for launching the DOS attacks. Let's go ahead with the rogue access point term. A rogue access point is a wireless access point that has been installed on a secure network without explicit authorization from a local area network administrator. Rogue access points can allow a hacker to conduct a man-in-the-middle attack, flood the network with useless data, creating a denial of service, send fake SSID advertising attractive features such as free internet connectivity, and provide a conduit for the theft of company information. Let's go ahead with the man-in-the-middle attack. In the man-in-the-middle attack, attacker secretly relays and possibly alters the communication between two parties who believe they are directly communicating with each other. An attacker within reception range of an unencrypted Wi-Fi wireless access point can insert himself as a man in the middle. Let's go ahead to the wireless local area network configuration. To configure a wireless local area network, we should choose the right network modes, SSID, channel width, channel and SSID broadcast, or we can choose the security application and the administration parameters as well. As you can see in here, we are choosing a security mode and we need to enter the password that we need to use while we are connecting to our wireless device. And also we should use a security mode and radius server. We can define as radius server or radius port as well. And we can make wireless MAC filtering, as you can see in here, and just allow these guys to enter our access point.